Okay, so we started with addition, subtraction, and multiplication of polynomials. And now we're going to get into division. So this week we're going to do two different methods of division. The first one is long division, and then the second one's going to be synthetic division. So synthetic division doesn't always work, which is why it's important to know how to use long division. Make sure with 1 and 2 of the daily review that you show your work. I don't know if you actually use long division if you don't show your work. And the process for polynomial long division is essentially the same process as dividing with numbers. So it's really important that you understand that, and I'll show you an example later with long division. You could also look it up on YouTube if you forget how to do long division. And then for 3 and 4, just simplify those expressions by dividing by 3 and dividing by a. So 4, 3, dividing polynomials, long division. It's a method for dividing a polynomial by another polynomial of a lower degree. It's very similar to dividing numbers. So this is what you learned way back in the day. Arithmetic, long division. So just a little bit about the information. In blue we have the dividend, in red is the divisor, and the quotient is the answer. And that's what we're looking for with these division problems. So we start with our dividend, and we look at 2. So 12 can't go into 2, which means we have to look at 27 then. So we know that 12 times 2 is 24, and 12 times 3 is 36. So we need to go into 27 without going over it, which is going to be 12 times 2. So you put the 2 on top of your division box, and then multiply 2 times 12 to get 24. And then you're subtracting, so it's repeated subtraction. So 27 minus 4 is 3. And then we're going to bring down our next term. So we have 37. So again, we just did 12 times 3 is 36, which means we put the 3 up top. So we want to go into it without going over. And then 3 times 12 is 36. And again, we're subtracting, so we end up with a remainder of 1. So if this were a polynomial problem and we wanted to write our quotient, well, we write our whole number part, which would be 23, and then we would write the remainder divided by the divisor, which would be 1/12. And we're going to write that with polynomials as well. So here's the answer to our division problem using arithmetic. So here's the first example of polynomial long division. We're going to start by looking at the dividend, but we're only looking at the first term of the divisor. So we're going to take the first term of our dividend, which is 2x squared, and divide it by x, which is the same as 1x. So 2 divided by 1 is 2, and then x squared divided by x to the first is going to give us x. So that tells us what we multiply by. So 2x goes up top, and then we have to distribute that 2x through our divisor. So when we distribute, we would get 2x squared plus 4x, which you can see is here. So with division, it's repeated subtraction. So we have to subtract both of those quantities. This cancels. 7x minus 4x is going to give us 3x. And then bring down our next term. So then we have 3x plus 7. So again, we start with our first term, which is 3x. And we divide it by the first term of our divisor, which is x, or 1x. And that cancels, and we just have 3. So that tells us what we need to multiply by. And then we have to multiply 3 times our divisor, which is x plus 2. So that's going to give us 3x plus 6. And you can see again that that's here. And we are subtracting both of these. So positive 7 minus 6 gives us 1. So our quotient, our answer to this problem, is 2x plus 3. And then we would have plus 1 over our divisor, which is x plus 2. So there is our polynomial expression for our quotient. And again, you can see the remainder is the numerator, and then the divisor is the denominator, and then the rest of this comes from the quotient that we found. And make sure you pay attention to your signs. Okay, so we'll look at 2 examples, and then you'll have 2 to finish for your notes for today. So our first polynomial goes inside the box, the division box, x squared plus 5x minus 28. And then we are dividing that by x minus 3. And I like to put that in parentheses so that you know that you can't split it up. So we're going to start with our first terms. So we're going to take x squared and divide by x to the first, which is just simply x. So that tells us what goes on top. And then we have to multiply x times x minus 3 and distribute the x through. So x squared minus 3x. And we're going to put that underneath. And then again, remember, we're subtracting both. So this becomes a negative x squared. If we're subtracting a negative, it becomes a positive 3x. So it's going to give us 8x, and then we have to bring down the minus 28. And then the same process again. It's basically just a repetition of the same process. So we take our first term, which is 8x, and divide it by our divisor, which is x. So the x's are going to cancel, and that gives us 8. So that tells us what's going to go in the box. You'll notice some patterns with this too. Notice this is x to the first power, so that's a linear term. And then this is a constant term, so it does decrease as you move from left to right in your quotient. So then we have to take 8, and we have to multiply by x minus 3. So that's going to be 8x minus 24. And again, don't forget we are subtracting. So minus, and then this is going to change to a plus. So that cancels. Negative 28 plus 24 is going to give us negative 4. So then we would have minus 4 over our divisor, which is x minus 3. And there is our quotient, again, which is our answer to our division problem. So x plus 8 minus 4 divided by x minus 3. So there's 1b for you to try. You should get a polynomial that starts with 5x for your final answer. Okay, 1c, we have a couple things going on here. Number 1, this dividend is not in standard form. So we need standard form, which means your highest exponent first, decreasing. It's got to be organized, otherwise it's going to be really confusing. So for a dividend. And then the next most important thing, and this is huge also with synthetic division, you will get the wrong answer every time if you don't do this. We need placeholder zeros. So what that means is if we have something like this expression, so ignore example 1c for now. Let's say we have 3x to the third plus 4x to the fifth minus 2x. We start with our highest exponent, which would be 4x to the fifth. We don't have an x to the fourth term, so we would have to put in a 0 x to the fourth. It doesn't change the polynomial at all, but it'll make the division much, much, much simpler. And then we do have a third term, so we'd have plus 3x to the third. We don't have a squared term, so again, we need a placeholder 0 for 0x squared. We do have an x term, which would give us minus 2x. And then we also don't have a constant, so we would need to have a constant of 0. So this now is in standard form with placeholder zeros. Standard form with placeholder zeros. So anything that's missing from our highest term down, we need to put in placeholder zeros. And that's only for division. It's not when you're rewriting polynomials in standard form. Okay, so back to 1C then. So if we look at our dividend, our highest exponent is 3. So that's going to be our first term. 2y to the third. And we do have an x squared term, so I'm going to put a 1 there just so we don't forget. So minus 1y squared. We don't have a y term, so there's our placeholder. So plus 0y. Again, if people make mistakes, this is one very, very common place where people make mistakes in the division process. And then we do have a constant term, which is 25. And then we are dividing that by y minus 3. So we're going to start with our first term, which is 2y to the third. And we're going to divide that by y. And we get 2y squared. So that goes on top. And then we have to multiply. So 2y squared times y minus 3. And when we distribute, we would get 2y to the third minus 6y squared. So again, this is another place where people make mistakes. We're subtracting both of these, so you change both signs. And then 6 minus 1 is going to give us 5y squared. And we bring down only our next term. So now we're going to take 5y squared and divide by the first term of our divisor, which is y. And that gives us 5y. So once we put something on top of our box, we have to multiply. 5y times y minus 3, which is 5y squared minus 15y. So subtract the negative, which is going to make it a positive. So we have 15y, and then bring down our next term, which is 25. And then one last time, take the first term of our new dividend, so 15y, and divide by the first term of our divisor, which is y. So the y's cancel, and that gives us 15. And again, notice how this is in our quotient here is in standard form. So we have a y squared, we have a y, we have a constant, and then we would have our remainder next. So it's very, very organized and structured. So we take 15 then, and multiply by our divisor, which would be 15y minus 45. And again, we're subtracting the entire quantity, so we have to subtract this and subtract a negative, which is going to make it plus. And then 25 plus 45 is going to give us 70. So we have plus 70 divided by y minus 3. And there's our quotient. Okay, so go back and watch this as many times as you need to. In order to learn how to do division, you have to think about it, you have to practice, you have to do things incorrectly, go back and fix them in order to learn how to do division. And as always, if you need help, make sure you schedule some time to have a Teams meeting with me, and I'd be happy to help you and explain anything that still needs cleared up.